All right, so good evening. Today's going to be class 16 of FOP, and today's going to be the continuation of creating a game using object-oriented programming or just classes and objects in general. Yesterday, we finished off the previous lesson, which was going to be which was regular expressions and ASCII characters, and we began this new lesson using the Python Pygame module. Yesterday we were able to get pretty far within our code. We had a working spaceship. We had the ability to shoot, but we didn't have anything to shoot at, and that's what we're going to be doing today. And hopefully today we should be able to finish the functionality of the game for the most part, and maybe even have some time to have some group time and work on some exercises, some individual work, and get a little bit hands-on or more hands-on on working with the objects yourselves. So without further ado, let me go ahead and share my code from yesterday's lecture. I'm going to talk through real quick about what we have for the sole purpose that that some people weren't here yesterday. They weren't able to due to scheduling, and we want to make sure that everyone's on the same level as everybody else. So let me know when you guys can see my screen. Just give me a thumbs up if you can. Awesome, thank you. All right, so on the left side, we're just gonna talk about the folder structure, right? So we have if you guys downloaded the repo or cloned it, you should have start off with a couple PNG files and your README. What I recommend you guys do is create a folder, name it assets, and then just put all your pictures in there. So it's away from your code. And then we're gonna create 3 different files. We start off with our main.py, which is what you're seeing here first. And this is what we initially started with to create our overall main game loop to have our game running. And then we have some secondaries and a third file here, one that held the class for our ship and one that held the class for the bullet that our ship was going to be firing. So we'll talk through the code first for the main.py. We had an import Pygame, which is going to be the module that we worked with. We import sys, which allows us to manipulate the actions of our windows of our computer, so we can actually exit out a window. And we kind of saw that yesterday. If you guys saw the recording or if you were here yesterday, that when we didn't properly code for our game to close the window whenever we were trying to exit, it wouldn't close. We had to force shut down the program because that X button on the top right or top left, whatever you have, wasn't working. So we used this to be able to manipulate that exit button. And then obviously we had to import the ships and the bullet whenever we had to use it. To start off, if you guys look at the README, we have some basic boilerplate code. And this is what you need to essentially begin your program was this. This was your the bare minimum. We had to import Pygame in the system, and then we created a class named game, right? That's the class game, which is going to hold the overall loop of our program. The first method it took was the init method, and within the init method, we gave it a couple parameters, and the main ones that actually matter to get the game running were from line 10 to 13 that we see here. We had to initialize Pygame within the init method. So we imported it, but we didn't start it up. So we have to make sure it starts it up just like you start your car or you start your computer and whatnot. Or kind of like when you start a computer, but you haven't logged in yet. You don't have access to anything yet, so you have to log into your account. Well, same method here. We had to initiate Pygame so we can have access to these methods. And then we created a data member named self.screen. And within this data member, we assign it our quote unquote window, right? And the window is received from the method that we got from Pygame. Pygame has this nice cool method called display.setMode. and it takes a tuple of width and height, and that's what's gonna create our game window. And then it takes we need to give it another data member, which is clock, and this is what's gonna track the frame rate of our game, right? So we have to initiate some form of clock so we can keep track of how many loops is going through, how many frames it's running through. And so we use the pygame.time.clock method that assigned it to this data member. That was the bare bones that we needed for our init method. And then we had to give our class an ability to actually run itself. So we created the method called run. It took no parameters or anything, but within this method, whenever we call it, we would run some form of an infinite loop where, the only way we would stop that loop would be if we manually press the exit button on the top right. Um, and what that does, it starts our game and it's just constantly running, right? It's running in a while loop, and while it runs in this infinite loop, essentially, we want to do something, and that's when we want to, write our code. So within this while loop, all this is what is actually making, our game work, which is what we see. Um, the bare bones of what we needed to at least get the game running within our while loop was coming out everything we didn't need was just these lines for event in pygame.event.get. So what is this for those of you guys that today's your first day? Well, Pygame keeps tracks of or checks of different events, right? So very similar to JavaScript. Whenever we're working with our HTML and adding JavaScript to our website, we can add an event listener to our buttons. So whenever we click on a button or whenever the user clicks on the button, it listens for that event of it being clicked and it can do something. That's kind of what Pygame does and how it runs, right? It's constantly checking events. Well, when it checks it, we need to be able to access them, right? And that's what we're doing here. We're looping through the events that it has. It stores it in some form of a dictionary, and then we're comparing the events that we loop through. And one of the events that Pygame has is the ability to quit, right? So Pygame is constantly listening, hey, has my user quit the game or not? And we want to listen for that. And in the event that we ran the command to quit, well, we actually want to quit, and it kind of it's kind of a little dumb how it's made, right? Well, obviously the user wants to quit, so why would he not automatically quit? Why do we have to manually code to quit? That's just how it is. Um, don't ask me, why it's built that way. Whoever built it in this manner. So we have to manually code for us to close the window, and that's what these lines from 30 to 33 did. And then on line 64 and 65, we do two things. One, we are updating our screen, and on line 65 is we're putting a cap at our frame rate. So every time this while loop runs, we update our screen. Think of it as a refresh button on your Windows browser, right? The Windows browsers don't have to continuously update because they're not dynamic in that manner. Like a game that's constantly running, you have pixels and characters and animation going on, so it doesn't have to be continuously running. But a game does, right? If you want your character to move fluidly from left to right without stuttering and whatnot, then we need to update our game over and over and over and over again, right? So it moves from one side to the other side of our screen. Well, the way that it does that, it runs in a loop. It's continuously updating every single pixel into its next state, right? And that's what this game loop does. It updates every time it loops through. And then we set our frame rate, and that's pretty much the bare boilerplate of our game. That's going to allow us to actually initialize something, um, and then we actually create an instance of this game here on line 68, right? So our class runs from the first line to line 65. After that, we exit out of our class. We're done creating it. We call the class game. Doesn't take any parameters. We assign it to our variable called my game. We can call this variable whatever you want, and then we call the .run method. And this is what's going to run your code initially. So if you guys, for those of you that just got here today, if you were to comment out everything that I commented out and you just run the bare boilerplate, it should give you a basic black screen with nothing on it. And that is your template, your foundation. Uh, After that, what we did, we created our ship.py, which was going to be our overall hero and our character. We isolated the code, kept it within itself, so it makes it easier to manipulate. And that is the main core of this objects and class lecture, is the fact that the beauty of object oriented programming is that we can create different code and be able to isolate it. And if we ever have to make updates or make a new class or make a change, it won't affect everything, right? We can just change the spaceship class itself without having to affect everything else that's already been published into production. And that's what's pretty cool about this. So our ship, it took an init method, and then it took a surface and a rectangle. I'm not going to dwell too much on how this works. Essentially, the way, just to give you a good idea of how it works, is that it works in layers, right? Our display is the base foundation, is the first layer of what our game is going to be. And if you want to put something on the screen, imagine like your background layer, that's going to be the next layer on top of it, right? Very similar, like a stack of papers or like a bunch of pancakes, and then after you put your background, what do you want to put? You actually want to put your spaceship and your enemies over that. What would happen if you put your spaceship or your enemies before, and then you put your background above it? Well, you wouldn't be able to see your spaceship or your enemies or your bullets or your animation, because you covered it up with your background. So we have to create surfaces, and we add a surface on top of our display, and then within that surface that we created, we can add stuff on top of it, and it works like that in layers, right? And that's kind of what we did here. The first thing here that you see within our init method, we created our space background. We create a new data member called self.space surface. The same manner that we create a display, we created our surface, gave it a dimensions of 800 by 800. That way it takes up our entire screen. After we created our surface, we wanted to manually put it on top of our display, right? It doesn't just appear on top of our display. We have to put it on top of it. And it's called blit, right? Whenever we add a surface on top of something else, or we add something on a surface, it's called blit or blitting, right? And we saw that here on line 54. We did self.screen, right? We got our screen, the display that we already declared before, and then we used the .blit method that comes with Pygame. And the two methods that it takes is whatever surface you want to add on top of it, or whatever image you want to add on top of it, and then the location that you want to start it at, right? And it, by default, uses the top left corner of your surface, your image, whatever you want to put on top of it, to orient it and place it. So I want the top left corner of my space surface to be at 0, 0. And after we created that, we want to add an image on top of that new surface we created, right? So we have display right now. We created a space surface, which is what we call it, space surface. Essentially, it's just another layer, right? We added that layer on top of our display. And then on top of that new layer that we just created, I want to add the image, right? We don't just put raw images on top of our display. We have to create surfaces that we can work on, almost like a canvas, right? And that's what we did here on line 54. We created our canvas, we added it on top of the display, and now we can actually put images on top of our canvas. And that's what we see here. We call the surface that we created self.space underscore surface. We're going to use the .blit method once again. And now instead of adding it another surface, we added the image to this one, right? And to add an image on Pygame, you use the pygame.image.load method, and then you put in quotation marks the location of whatever image you're trying to add, and then where you want to add it within here. And after we did that, we were able to run this, and we get a cool, nice looking image here, which is going to be our space background, right? So we did our space background. And in the same manner that we did this, that's how we added our spaceship and our bullet, right? You kind of see it here later on my code. We drew our spaceship, and I'll say why we drew it in a bit instead of blitting it. Well, because we created a built-in method within our class that took care of the .blit method, and I'll show you guys that in a second. Right, so after we did our space background, we created our hero here. We defined the init method. We loaded the image the same way that we had loaded the space image on our main.py. Well, now we're working within an individual class. We might as well just save it into a data member. So we took in the image for our spaceship, right? So whenever we create this instance of this spaceship, whenever we create it, it should be able to take in an image as an argument, and then the location of where we want to place our image at, right? It's going to be our X and Y. So it's going to take those three items as a data member or arguments. We use the image that's passed in there, and we save it to this variable called self.spaceship surface, right? And then we have a new data member here called .rect. And why? What is this? Well, the way that games work in Pygame is, it's surrounded by rectangles. If you guys ever seen like the raw production and construction of video games or animation in general, typically it's a bunch of blocks, right? But before they add any kind of features, they have blocks and whatnot. Almost think of like quote unquote hit boxes, right? Very similar to like Call of Duty. Whenever you get hit, how does the computer know that your character got hit? Well, there's some invincible like in some invisible boxes that surround your character. They're hit boxes. Well, to their bare bones, they're essentially just rectangles or boxes that surround our characters. And we're gonna need to create some rectangles to be able to determine collisions within our game, so we can identify when our bullet hits the aliens or enemies, right? Or whenever the alien hits us. Well, how do we tell that? Well, Pygame is able to grab one rectangle, it's able to grab a second rectangle, and it's able to tell whenever either one of those rectangles touch or intersect each other. And that's why we're going to add a rectangle to our spaceship. So we do that here. We declare a data member called self.rect. And the way that you put a rectangle around an image, well, you call the image that you want to put a rectangle around it, and you do something as simple as using a built-in method that Pygame has called get rect, right? So we do the get rect method, and then we want to place the rectangle. How do we want to be able to manipulate it? Well, we're going to use mid bottom, and that's just syntax. Unfortunately, I can't spend too much time on this of how the syntax works. I can show you a quick picture of how we play stuff. Essentially, it will look something like this. Can you guys see my screen of the picture? This is how Pygame works. Whenever you put a rectangle around an image, this is how you manipulate the placement. You have top left, top right, bottom left, bottom right, mid left, mid top, mid bottom, and you even have center. This is just a quick little image to help you guys visualize that, and that's how we were able to manipulate our rectangles. So I call it mid bottom, and I want to place the mid bottom of my spaceship at whatever coordinates I assign to it, right? So it takes this argument and it adds it into this data member here. And that's pretty much the basics of my spaceship. I created a getter method to be able to receive its position. So get position, it'll give me the X and Y of my rect, right? And then I created a method here called draw, right? And as we see here, we see something very similar. We see screen.blit. Well, the exact same functionality I use in my main.py is what I use on my spaceship, right? So I use screen.blit to add the space surface onto my display screen, and then I use the .blit method again to add an image to my space surface. Well, I took that functionality and I added it into a method within my spaceship class called draw. That way, I don't have to do it within my game class, because if I did it within my game class, the way I would have done it is I would have to do I call the data member within my game class, which is going to be the space surface, right? Because I want to add my spaceship within my space surface. I would do .blit, and then I would have to grab the image of my spaceship, but that's within a data member. So I would have to do like spaceship dot image or whatever it would have been. What if it's a private data member, or if I had to use a getter method to grab that image? I didn't want to directly access those data members. So I just did all that functionality within my shape class to avoid having to manually grab it from in here. And that's how I created that draw method. And we see that here after I create an instance of my spaceship up here. within the init method of game, I had imported spaceship within here. I created a data member within my game class, self.a spaceship, call the class, pass to the image of my spaceship, and then where I wanted to add it. And then now that my image is actually created in an object, I can use that object and call self.draw over here, and it adds my spaceship, right? Well, I'm gonna stop there with the explanation, and we're gonna keep moving forward for the sole fact that I've already wasted a lot of time on explaining. But hopefully, this kind of gives you an idea of what all this stuff means. And then as we run into something new, I'll explain it as we talk through it. So this is how we ended up with our game. Uh, if you guys code along with me, if you have the code that I gave you guys, then we should be up to this point where we have a nice little background. We have a spaceship that can move using the WASD and then shoot with our mouse button, which is pretty cool, right? But up to this point, what are we missing? Well, we don't have a way to actually, shoot anything. It's cool that we have firepower now, but what's the point of having all this firepower if it does nothing for us, right? So now we actually need a target. Everyone loves a nice hero story, but a hero story isn't complete without its arch nemesis, and for us, it's going to be our alien invaders. So up to this point in our code, we have a working spaceship with the ability to defend itself if needed, but no hero story is ever complete without having an enemy to quarrel with. So next, we are going to work on our enemy.py, right? Either enemy.py or alien.py, whatever you want to call it. For this explanation, I'm just going to call it alien.py. So within your Pygame folder that you created, along with your main bullet and shift.py, I want you to create an alien.py. And this is going to be the class for our overall enemy. And now that we got our alien.py, what we're going to do is we're going to, once again, we're going to import Pygame. And we're going to use something specific this time that our bullet class didn't use. It's going to be the random module. All right, so we're going to import random. Now, why are we using random? Well, if you guys look at the assets, I have 3 different spaceships there. All right, I have the green alien, the red alien, and the yellow alien. Well, how are we going to know which one to spawn? That's where the random module is going to come into play. Randomly, whenever an alien spawns, I want to grab one out of the 3 and spawn them, right? I don't want to just loop through red, yellow, green, red, yellow, green. I'm just going to go ahead and just choose something random, and we can use that to our advantage. So after I import that, I'm going to create my class, alien. And as mentioned before, with the bullet, we had to be able to manipulate multiple bullets at once, right? Well, how are we going to be able to move every single time? Every single time we shoot, the bullet's going to move. How are we going to keep track of all the bullets and their position and how far they have to move? Well, Pygame allows us a nice little way of being able to manipulate that, and that's going to be using the sprite class, right? So Pygame has a built-in class called sprite that we can inherit from and take some built-in methods that it already comes with. And that that's one of the cool things about objects and classes is that you can inherit from other classes the same way that you, Roger, inherit your hair from your dad or your mom. The same way that this class is going to inherit from another class, right? The same way that you guys inherit the fact that you can snap, right? Or for those of you that can lick your elbows, and some of us can't, you inherit these very traits. We can do that with these classes, right? And why rebuild the classes and methods that we need when we can just inherit it from somebody else that's already done the legwork, right? And Pygame has a class called pygame.sprite. Make sure the second sprite has a capital S in there. This is going to give us access to these special methods that's going to allow us to keep track of all our classes. Then we're going to initialize our new class. Just like every other class, you find init, it's going to take in self. And now the way that we inherit from another parent, we're going to have to initialize their methods within our init method, right? We don't just type it in here and expect to have access to it. We actually have to turn them on. And the way that we're going to turn them on is going to be the first thing that we put within our init method. We're going to retype again, pygame.sprite in the same manner that we put it in the parentheses. But now we're going to call this class's init method. So dot underscore underscore init underscore underscore, and then pass it itself. So just the same way that we initialize our own methods, if we inherit from somebody else, we have to initialize their traits within us. And that's what we're doing here, right? So now this is going to give us access to all those extra methods that come with it from our parents. And now we can actually start defining our new alien class. So we're going to create 3 data members, 1 for each alien. So we'll do self dot, I see my first alien here is going to be green alien. So I'll say green alien is equal to, and then I'm going to load my image using the pygame.image.load command, right? Another method that comes from pygame. And the only argument this command takes is the actual location of our image. Here I have it within my assets folder. So I'm going to say assets / and then the name of my PNG, which is going to be green alien.png, right? And now this is going to load that image within this data member. Next, I'm going to do the red alien and then the yellow alien. So take some time to go ahead and code that in the same manner that we did the green one. There's my red one.
To save you some heartache, you got a typo in alien on line 8.
Thank you. Where? Line
Just
8.
in your actual variable name.
Oh, that would have killed me. I appreciate it. My keyboard's still broken. I never bought a new keyboard because I'm just like that. I'd rather go through the headache than spend money. Oh well. So I got.
I'm just bad at typing, so you're good.
So now I have my images loaded within these data members, and now I'm going to create a new data member called spawnable aliens. You can call it whatever you want. You can call this all aliens, whatever. I'm just gonna call it self.spawnable aliens, and this is gonna be a list. Within this list, I'm going to pass it all 3 aliens that I just created. Now, could I have done this without creating 3 data members? I could have, but I would have had all that code from line 8, 9, 10 within this list, and I didn't want to do that. So I just rather do it this way. Red alien. Right? Essentially, I just added all 3 of these images within this list, and that's what I'm going to use to create my different types of aliens. Then I'm going to do self.image. Right now, I'm actually going to create that image surface of what I want to use, and then within here, I'm going to do self.spawnable aliens, open and close brackets, and the index I'm gonna give it is going to be random.rand int, open and close parentheses, and then I'm gonna give it 0 to 2. Now, what is this? Well, this is a method that comes from the random module, right? For those of you guys who are familiar with it, it's just a method that comes from the random module. How you grab a random number, you give it the range from start to end of what you want. I want either index 0, index 1, or index 2. Right? This isn't like one of those from like in range of, and then it's up to 2, but not including. This one will actually include the number. So we have to put the 2, not 3. So whenever we create an instance of an alien and it gets to line 12 as it's initializing it, well, the index that's going to get here is going to be absolutely random. And that will allow us to have some flexibility of what type of alien we create without us having to manually code it every single time. Then we're going to create the rectangle that's going to go around our alien, just like we did for our bullets and for our spaceship. So we're going to do self.rect is equal to self.image, right? Whatever we're going to put it around. And we have that data member already created called self.image. And then to create a rectangle around images, we use the getRect method. And now, where do we want, or how do we want to manipulate this alien? I'm going to want to manipulate him using the center. Why? Well, because they're going to be moving all over the place, right? I don't want to specifically grab the top left or top right or mid top, mid bottom, because there might at one point they're going to be on the left side of my screen. Sometimes they're going to be on the right. They start up at top, and then they're at the bottom. So I'm just going to grab them dead center. That's just personal preference. So I'm going to do center, and then it takes in a tuple. I'm going to give it 20, 20. Right, that's where it's going to initially start at, right, at at that pixel 2020 location. Now, I'm also going to create a data member that's going to keep track the direction that they're moving, right? And we won't have to use it just yet, but I'm just going to go ahead and declare it before we even get anywhere. And it's going to call it going right, right? And it's going to take a Boolean. I'm going to pass it true, right? What happens is they're going to spawn at the top left, and they're going to immediately start moving to the right side of my screen. And then I'm going to switch it to false so they can move to the left, and so on and so forth. Right? That's going to allow me to keep track of that movement for the alien. And that's going to be it for now before we have to come back and do anything involving our alien. And those for you that were here yesterday, now that we created our alien, what do you think is going to be the next step that we have to do? The alien's there. How do we get this aliens or these aliens onto our screen? Any thoughts? Even if they're absolutely wrong, I just want to hear what you're thinking. What was that, Jasmine?
Editing the ignition? I don't know.
What do you mean the ignition?
Yeah.
Any ideas? No ideas at all? Kara, what's that?
What about like at least linking the alien file to or the class to this main class?
Yeah, that is the very first step. You are correct, right? So we will have to have some kind of access of that because we have the class blueprint. It's within the alien.py, but we don't have access to it in our main.py. You correct, Adrian, creating the object in the init. You are absolutely correct, right? So we need to actually create the object. We have the blueprint, we have the recipe to how to create an alien, but right now there's no alien that exists, right? If someone wrote down what your features are, Roger or Jasmine, like this is the blueprint to Roger, this is the blueprint to Jasmine. Is that you? Well, no, you haven't spawned. You haven't been birthed yet, and that's what we have to do now. We have to create the object. We have to instantiate it. It's the term that we use, right? When talking about objects and classes, we have to instantiate that object. Well, let's go ahead and import our recipe or our blueprint. So from alien, import alien. All right, we're gonna import the alien class. We created a spaceship here. We created bullets. Well, we now want to create aliens. And aliens, just like the bullet, it inherits from a sprite class, right? We're going to have multiple aliens, not just one. And as I talked to you guys before yesterday, well, there has to be a way to be able to track every single alien And there is, right? The class that we inherited from allow us to create groups of these bad boys. So just the same way that we've created all bullets, where we keep track of all the bullets that are spawned, we're gonna do one for aliens. So all aliens. And then we're going to, within it, assign it and call the method pygame.sprite.group. Now, for those of you that are new here, what is this command? Well, essentially what this is, it's, at its core, it's just a dictionary, right? At its core, it is just a dictionary. But this is a very specific dictionary that's built into Pygame that has some nice little methods, right? That's going to allow us to grab things from there. So essentially, at its core, it's just a dictionary of whatever sprites we add into it, right? At its very core, that's what it is. But it has some additional features, and some of the features that it has are some built-in methods. The built-in methods are like .add, right? That's how we add new stuff to it. .update, it allows us to update every single item within that dictionary. These are just methods that are to Pygame, right? So they're unique to Pygame, and which is why we inherit the sprite class, so we can use these methods that it already has. If not, we would have to manually grab like every single item and manually code every time that we want to grab something, right? So essentially, if I wanted to update every single item within this variable, and you don't have to code this, is just an example, I would have to do self.aliens.update, right? It has a built-in method called update, and what this will do, without me having to code it out, it'll loop through every single item and it'll call that update method for everything that's in there. If I didn't have this sprite class that I inherited from, I would have to pre-build this method myself, and I would have to code it. I would have to do for aliens and self.aliens, and then aliens.update. I will have to loop through every single time and code it myself, but I don't have to do that because I've inherited from my parents, right? That's what this method is, and why classes are so cool, because we can inherit from them, and it saves us from having to rewrite all this code. So we create a variable called all aliens, which is going to hold our sprite. And now that we have somewhere to put these bad boys, we actually want to create them. Well, how do we want to create them? Do we want to do it, every time we click, or what should it be? Should it be random? Well, we'll keep it simple. Essentially, we want to create some form of a timer, right? We want to track, how often they spawn, right? They shouldn't just spawn sporadically, because we might get overwhelmed, depending on the randomization. I want to control how many times something spawned and how often. And Pygame has a nice little pre-built method for that, right? And we can create a timer. And to do that, we're going to initiate a new data member. We're going to call this self.enemy spawn timer. This is where we're going to hold our clock at, right? And the same way that we're checking for events to see if we've quit, the same way that we check for events to see if we click a mouse button, or the same way that we check the events to see if a key was pressed, well, we can create our own events, right? I don't know if you guys knew this, so we can create our own events. There's pre-built events that Pygame automatically listens to, but we are able to create our own events, right? And to create an event, you're going to use the Pygame.user event method, right? It's going to be all caps, and then you do +1. What this does is going to create a new event, and then it's going to assign it to the data member called enemy spawn timer. We do the +1 because there's already events that are to Pygame, so we don't get any weird functionality. We have to do the +1. Don't think too much about it. Just know that that's the syntax for Pygame, right? We're gonna do a +1 to add an additional user event to our Pygame. So now we're listening to something new, and what we're listening to is gonna be the enemy spawn timer, right? That's our pre-built, customized event that we made. And now we're going to set the timer. So we're gonna do Pygame.time.set timer, and this is how we set our timer that we created. This method is going to take the timer that you created. So whatever timer you want to pass it, for the first argument, and the next argument is going to be the time in milliseconds, right? And I'm going to do 500 milliseconds. So that means every 500 milliseconds, I want to run this event, right? That's what this is saying. I'm going to want to run this event. Everyone still with me? Now, how do we actually give me a second. Give me a second. I'm trying to get my bearings on my code. So we create our timer. We have our bullets, but now we have to actually add our aliens. As a matter of fact, actually, while I get my bearings on my code, let's take a 10-minute break. Because we're about to reach that point anyways. Come back. The time is 6:18. Come back at 6:28. Let me share my screen. We should be back from where we're at. All right, so we created our spawn timer, right? Essentially, all this is really doing is it creates an event that we can now listen to, right? We just essentially just did an event listener, right? And then we want to run this spawn timer every 500 milliseconds. Well, now that it's running, right, this is going to be initially a new event, and now this is happening every 500 seconds. It's happening. Well, now we want to listen to it. So in the same manner that we listen for the .quit event, in the same way that we're listening for the mouse button event, we're going to listen to the new event we created. So we're going to do if event.type is equal to self.enemy spawn timer, right? So if one of the events that we're listening through while we're running our while loop ends up being the enemy spawn timer, then guess what I'm going to do? I want to create a new alien object. So I'm going to create this variable called alien object, and then within here I'm going to use my alien class. Let's just double check. What does my alien take? It doesn't take anything as an argument, so it's gonna be empty. Now that is our new alien object. Well, our alien object is created, but now we need a method to actually put it on our screen. It's not on our screen or anything. It exists, but it's not on our screen, and we can kind of see that, right? I can actually print out this object and see it work. I'm getting some issue here, some syntax issue where line 1. What's going on? Oh, I think it's my bad. I was within Python. Okay, so now it is giving me an issue. No file assets yellow alien found in working directory. Okay, that's weird. That's suspicious. So let's check it out. It says there is no alien found. So the error was found in my alien.py, right? So it went to my main.py. It got to line 46 where it wanted to create my alien object, right? This is what this is error saying. And then the next line here says on line 10, right, on self.yellow alien, it couldn't find my assets yellow alien because I forgot .png, right? So it couldn't find the file properly. So let's run that again. Now it's running, and we can see here in sprite, it's printing out that every time it creates it in 0 groups, right? Because our groups typically, or whenever we talk about indexes, we start at 0. So that one group that's created of sprites of aliens is there, but I'm constantly printing out. So my alien sprite exists, but it's nowhere specifically. Okay, so well, we have that we know it's being created, so now we actually have to add it to that all aliens group that we created. So the individual alien is created, but now we need somewhere to track all these little aliens. So we're gonna do self dot all aliens dot add, and then I'm gonna pass it in the entire object, which is my alien. And let's see if we can print that out. So we're gonna print self dot all aliens. Let's see what that gives me. Let me clear out my terminal so you can kind of see. Group 1 or and whatever this group is, 1 sprite, 2 sprites, 3 sprites, 4 sprites. So it is creating instances of aliens, and I'm printing out my group, and it's telling me how many sprites is within there. Up to this point on this game, I've created 35 sprites, 36, 37, and it's continuously creating aliens. Awesome. Well, I know they exist. I know I'm keeping track of them, but now I actually have to paint them onto my screen. Let's get rid of that print. And just like everything else, we're gonna have to draw them or blit them onto the screen, right? So we have we blit it or space surface, and then we added a draw method to the spaceship and the all bullets one, so that it adds that functionality within my my bullet and my spaceship class. Well, I'm going to do something very similar to my alien class, right? I'm going to give it its own functionality as well. So give me a second. Oh, correction. I don't have to give it a dot draw method. Why is that? Well, the ship wasn't a sprite, so I had to give it its own draw method. I had to manually create it, right? Because it didn't have one. It wasn't a sprite. But if you guys remember correctly from the bullet one, I was able to inherit the dot draw method from the sprite parent class. And that just naturally comes with the sprite class. So I don't even have to create no method because we already have it. So within here, all I have to do is just do in the same manner that I'm drawing all my bullets. I can grab the alien group, self dot all aliens, and say dot draw. And then where do I want to draw them on? I have to give it a surface. Well, I've been putting everything on my space surface. So I'll pass the surface. And then let's run this. And we see here in the top left, it's creating my aliens. Ain't that awesome? So now we actually see these bad boys coming to light. And we know their objects are being created. And what's happening? They're kind of overlapping. Well, because we haven't updated them. We're creating every single space alien in the exact same location. So they're just overlapping, right? They're just overlapping. Well, that's not what we want them to do. We actually want to give them some functionality, and we'll get that to a bit. Right now, they're there. I can't even hit them from where they're spawning, so I can't even spawn camp them. And I can't even get up to them because I set a limitation on the movement of my spaceship of how far they move up. Well, just to cover how that's done, and if you guys remember correctly, Roger and Adrian, right? As I mentioned, this is the event loop pretty much. This is checking every single time my while loop is running. It's checking for events. That's what this code does. It checks whether I quit, right? So it runs a for loop within the dictionary of my events. Pygame naturally has a dictionary that it tracks all the events that happen. So I have to put that for loop so I can loop through this dictionary and check whether one of them is a dot quit, whether one of them is a mouse button down click, right? Whether one of the events that are happening is the enemy spawn timer. So that's what that is doing. After you have that basic functionality, every time this loops, it's going to run all this over and over and over again. So every time I run through this loop, I'm checking whether I'm moving left, right, up, or down. And that's what that does. I grab all the keys. What the dot get pressed method does in Pygame, it returns to me a dictionary of the status of every single key on my keyboard, right? I assign that to the variable keys, and then I check the keys within it. If one of the keys that is being pressed is either A, if one of the keys that I'm pressing is either D or one of them is W, one of them is S, and if so, I will do something, right? And we see that here if pygame.k_a, this is the code for the A key. This is the code for the D key, the code for the W key, and the code for the S key. If that key is being pressed, then I'm going to grab my spaceship object and I'm calling the .move method that it has, and I'm passing it a string variable of whatever my key is going to be, either A, D, W, S. That's how that works. So every time my while loop runs, it checks if I'm moving, right? Every time my while loop runs, it's going to add my surface onto my screen. It's going to add the image to my space surface. It's going to add my spaceship on top of that image. It's going to add my bullets, if I have any bullets, on top of that space surface, and then it's going to update them. It's going to add all the aliens, and this is running like 1,000 times a second. Probably not literally. I don't know what the speed is, but it's running a lot of times every single time that the while loop runs. All this runs. So that's how that works, right? So every time this runs, I'm running the all aliens and then I'm updating it. And that's what this does. It just updates and refreshes. It refreshes your page over and over and over again in such a fast rate of speed that you don't notice it. But that's how this works, and that's how your frames work. So we added the bullets, we added the aliens, and now we want these aliens to do something, because it ain't fun if they ain't fighting back, right? So we're going to go to our alien class, and we're going to create an update in the same manner that bullet has an update. And let's look at that. Let's look at bullet's update. It has the update that increases or actually lowers its Y coordinate by 10 every time that I call the update method, right? And that's how I've handled the movement from my bullets, right? The sprite group naturally already has an update method, but its default code is very basic. I don't even think there's anything in there. So we have to override it and create our own unique code for whatever we're inheriting it to. The bullet, the only kind of update it needs to do is move, right? I need to update its position every single time. So every time I call the update method for my bullet group, it's going to lower the Y coordinate for every single bullet within that group by 10 pixels. That's what that is doing, right? So we need to do something very similar to the alien one, right? So the alien inherited from the sprite class, so it also has an update method, but it doesn't have anything specific. So I'm gonna have to override it, and this should take no parameters, right? It's gonna be my update method, takes no parameters. And now, how do I want to do this? Who can kind of talk the logic, or someone talk to me? How would I do this? What kind of logic do I want, and how should I do it? What algorithm should I take, or what path should I take? We know that its coordinates is going to be at 2020. And just real quick, I do apologize that I'm explaining everything. I do want to make sure everyone's on the same page. For those of you that today is your first day of going over this with me, the way that we read the coordinates on our screen is from top left downwards, right? So the top left of our screen is at 0, 0, right? Our x coordinate is measured from left to right. So if we wanted to know what our x is, 0 is here. Halfway through my screen, right, would be like, if the size of my screen is 800 by 800, right? X is 800, Y is 800. 0x would be on top left. 800x would be the top right, because it moves from left to right. So as I increase my value of my x, I'm moving right. As I decrease the value of my x, I'm moving left. And then for the y, if I increase the value of my y, I'm going down. If I decrease the value of my y, I'm going up, which is why my bullet is, I'm subtracting the coordinate of y by 10, because I want to move the bullet upwards, right? That's why that is doing what it's doing. So back to my alien, it's going to start at coordinates 2020, and as we saw, let me put pass here so it doesn't give me an error, right? As we saw, 2020 is right here. right? It's grabbing it by its center. So 2020, it's probably gonna be right here where my mouse button's at. That's where 2020 is at. It's grabbing its center of my image and it's pasting it there. Well, I want this to replicate this Space Invaders arcade game that I'm essentially trying to do. He should be able to move right. Once he reaches the far right side of my screen, he needs to move down a little bit and then move left. Right? So, how do we do that? Who can talk me through?
Would it be self react x self dot react dot x plus equals 10, and then if reach the other end of the screen, I don't
You're
talking
good.
out my
You're
ass
on the
right
right
now,
path, right?
but
You're on the right path, right? Yeah. So you're
yeah,
gonna move the
and
coordinates.
then
It's not a reach or react. It's rect, right? So rectangle,
rect,
right? It's okay. No issue there. But yeah, we're gonna want to manipulate our rectangle, our self.rect data member. We want to manipulate that and shift it left, right, up, or down, right? And that's where the data member on line 14 is going to come into play. Our going right is equal to true, right? So we need to know what way are we moving? Are we moving left or right? So if self dot going right is equal to true, we should be able to increase the x-axis, right? If it's equal to false, it should be able to decrease the x-axis, and so on and so forth, right? And then once it reaches a certain part of our screen, I need to know that I have to move my character to go down, right? And this is going to be one of the exercises that we're going to do today. So you guys can manipulate the object. So I'm going to break you off into teams. We'll just do 2 teams. We'll split Roger and Adrian up. So there were someone that's up to speed and it can run Pygame effectively. So we'll pause here.
It's not moving left and right.
Yeah. Okay. Well, I wanted you guys to try it out, and awesome. I'm glad we did do that break because that gave me some time to help Roger and Adrian debug their code. And we're gonna move forward. The issue was whenever I copied and pasted the code into Slack, I think I forgot to add the update method. So that's not on you guys. That's my fault. Honestly, I'm pretty sure I copied it all. I think Slack had a size or word limit to how much you can copy and paste in that code block thing. And I think that's what it was. So I do apologize for that. But now we can go ahead and move forward. We're going to go ahead. Let's share my screen. So we left off here on updating the alien. So we have a working game so far. We have movement, we have shooting, we have the alien spawning. That's awesome. But he ain't doing nothing, right? And ain't nothing fun about them doing nothing. We got them to do something. So let's get that functionality working. I did leave you guys off. I gave you a clue of using this variable, the going right. You guys didn't use it. I don't know why, but we want to be able to track multiple things. We need to track whether what direction they're moving and if they've reached the limit that they've moved at, right? So to do that, we're gonna use that data member, right? And let's go ahead and start coding that out. So we're gonna do if we're going right, if self dot going right is equal to true, then we should be able to move our x-axis in the positive manner. So we should be able to do something like self dot rect dot x plus equals 5, right? Else we should move in the opposite direction, right? We'll see this. We can visualize this real quick. Let's run it. Oh, it's not doing anything. Why is that? Well, because I'm not calling it. So let's go back to my main.py. I drew them here, but we gotta actually update them. So self.allaliens.update. So I want to explain something that I saw one of the groups doing. They created a whole new method and they try to use this method on the groups of sprites. And it didn't work. Why didn't it work? It's okay, Jasmine. You don't have to hide your face. But I'm gonna explain what happened, right? And it's not wrong. Like I like the route you were going, but it's a good learning point for all of us. Why couldn't we use the dot draw method on all the groups, right? Well, because it's the class that we inherit from. Partially it's a Pygame thing, right? The sprite group that we inherit from already has certain methods that you can call upon. That update method comes with the sprite parent class. It's already with the sprite parent class. So being able to use the update is built into the groups already, right? That is the functionality of having the group, right? We have the parent class sprite, right? But the parent class sprite, we can't just call their individual methods from the group. It's out of scope almost, right? We have to use the dot update method that comes with. That's why we put all that functionality within it. All we're doing is overriding it, right? And that comes from objects and classes, right? Part of an inheritance is that we can use polymorphism. What does that mean? We can take some stuff that we got from our parents and override it because we don't find uses in it, or it's not exactly what we need, right? We're able to use our parents as a blueprint to create children, but sometimes our children are going to go their own ways, right? They're not always going to be exactly like the parent. We want to have some kind of, individualism, like, uniqueness of our classes. And we have that ability by overriding any kind of methods that we've received from our parents. And one of them is the update class. I'm sorry, the update method. The update method is very, very bland, doesn't really come with much code. So it's there for us to override it and put what we want to put in there. And that's what we're doing. So we're gonna have to use the update method to work with the movement. So we created that update method, we added it to the self.aliens, and we can run this on main.py, and we see them moving now. They're actually moving, but they're moving right out of the screen. They need to be able to stop at a certain limit and then shift down and change direction, right? So they're doing that. They're working to a certain extent. So now that we have that within here, we're going to say, or we're going to do a check. If self.rect.x is equal to 760, that's going to be my limit. I already pre-calculated this measurement, right? So that's where I'm getting this number. I've already run my test. I can do 800 to show you its raw form. 800. And what's 800? That's gonna be my far right limit of what my window is. If it reaches 800, then in that situation, I want to make sure they come down, right? So I'm going to change my Y. So if my X is equal to 800, that means they've reached the far right limit. Then I want to move them down. So I'm going to do plus equals, let's say 50. That'll move them 50 pixels down, right? And that means if they've already reached the far right limit and they move down, they should go the opposite way now. So that means that self-dot going right is going to have to equal false. All right, so I need to change the value in false, right? Let's see how that works, right? We can run this. They're going to move all the way to the right, and now they shift down and move left, right? Awesome. They're kind of going out of the screen. So, I've already ran this code before, so I already know that my sweet spot is going to be 760, and that's just because I'm shifting them from their center point, and the size of my actual sprite, I have to compensate for that size. And using 760 is going to give me that sweet spot that I'm looking for, right? And we can see them shift downwards, right? And now they're stopping. Oh, they're stopping on the right side, but now they're going off screen on the left, and that's not what I want. So we have the movement right. And then once they reach their limit, it's going to equal false, right? And I've already kind of started that here. So if going right is equal true, I want to do everything within this code. If it doesn't equal true, then I want to do something else. That means you're going to be moving left, right? And then I'm going to do pretty much what I just did earlier, but in the opposite direction. So if self.rect.x is equal to, let's say, 0, right? If it reaches the far left of my screen, then I want to move them downwards again, right? So they can go from right, down, left, down, right, down until they reach the hero or player or spaceship, right? And if they've moved down, then I should go the opposite way. I should now go right. So going right is equal to true. Oh, I'm comparing there. I have to assign. And if done correctly, this should give me the functionality that I'm looking for. They go right, they hit the far right limit, they go down, they move left, and wow, they do exactly what I was looking for. Isn't that freaking awesome? This pumps me up, man. Some people get excited with money. I get excited with pixels. I love it. Isn't that freaking cool? Now, I'm gonna get overwhelmed. They're gonna kill me. I'm not doing anything. We got an alien invasion. Live outside of Earth exists, but we have to find a way to get rid of them. The enemies there, our heroes there. We have some way to combat them, but now we actually need to add some kind of functionality between them. And this this isn't nice, right? That's happening here. This isn't a full game. So that took care of that. We now have that movement, right? So we got the alien class in there. With the alien class created, we want to create a new sprite group. We did that already. We set up the timer. So it's cool and all, but no one likes a stationary target. They're able to move. They got that functionality down. Finally, we can draw our aliens. We drew them. So we have a movable spaceship with firing capabilities. It's a dangerous foe. It feels like we're almost at the end, but the core concept isn't there yet, right? We need some actual functionality there. We want to see if our bullets actually hit our targets or not. And to do that, within our bullet class, we're going to tweak our update code a little bit, right? So we're going to go to our bullet class. Now the rectangles that we've created around the bullet class, the hero, and the aliens are actually going to matter. This is the main reason for rectangles or self.rect. This is what's going to allow us to track the collision between our hero, the bullets, and the alien, and actually, either end the game or terminate the enemy and erase them from our screen. So within the bullet class, we're going to use a pre-built method that comes with Pygame. It's called Sprite Collide, right? We're gonna say Pygame.sprite collide, right? And what this does, it takes two arguments. It's you call it within a sprite group, and then it takes another sprite group as an argument, and the second argument is gonna be either true or false. It's gonna be a Boolean. What that true or false is whether you want to remove that object from the sprite group or not. So within here, we should be able to take something like well, it needs self, right? It needs to take itself, right? From whatever sprite group is calling it. So it has to take in self. It's going to have to take in an argument that we're going to pass it, which is going to be alien group. And then we have to pass it the Boolean, which is going to be true. So within our update parameters, we have to now take a new argument, which is going to be alien group. So whenever we update, we need to pass in within the update method of our bullets, the group of aliens. So we can make that link between our bullets and our aliens, right? So that's that method that comes pre-built with Pygame. And then we're going to say if self dot rect dot y is equal to -50. I want to do self dot kill. Now, what did I just do? Well, as you guys saw earlier, when I was shooting, I was printing out the sprites in the sprite group. The number just kept going on. Is that functional? Should we keep objects that we no longer need? What happens to the aliens once they pass through us? Or what happens to the bullets if we miss and they go past our screen? Well, essentially they still exist, right? You don't see them because their y-axis is like -0, so it's beyond our screen window, but they still exist. If you guys remember to yesterday's class, whenever I didn't set a limit to my spaceship, I was able to move left, right, down, and up outside of my screen window. The objects still exist, so we need to get rid of them. Why is that? Well, because it's going to overload our system, right? This is just good game development. We just want to delete a sprite if it's no longer needed, and the bullet is essentially a sprite. It's an object. It's an object we've instantiated that we no longer need. So we're going to check the y-axis of the bullets, and once they reach -50, which is above our screen, then I want to remove that bullet. And there's a method called .kill that's within our sprite groups that will essentially delete that object. And that's what line 14 and 15 are doing. Does that make sense? And honestly, that's all the functionality we should need if we run our main.py. Oh, I got an issue here. It says bullet.update missing one required positional argument. It's missing the parameter. So if we go to our bullet line on line 66 for me, I'm updating my bullets, but now I've changed it, right? I added a new argument that it needs to take. It needs to be able to compare itself within the other aliens. So I'm gonna do self.all aliens. That is a group that it's going to compare itself with. Let's run that now. What's going on? Bullet.update. What is going on? That's my bullet class. It takes in an alien group. Okay. We got self-direct, cool. And then my main.py. I need to check what's going on. Stand by. Oh, I'm pretty dumb. There's something else. It works. Yeah. I knew I didn't mess up. It was a typo. All right. Now that we fire, we're able to see that the aliens are disappearing. It is working, guys. We have a functional game. The moment that bullets make contact with an alien sprite, it deletes it from our screen, essentially removing it from the sprite group, and we now have actual working functionality within our bullets. Isn't this freaking cool? I'm going to pause here real quick. Does anybody have any questions? Adrian, we're killing now. Yes, we are. We're putting them to rest. Anyone have any questions? Are you guys all up to speed? Any errors in your code? Are you guys having some difficult?
Can
I
you
see
show the
the,
bullets code again?
Come again?
Sorry, can you just pull up the bullets .py again?
Yeah,
I
of course.
missed. I fell
and then
behind.
the alien.py after that, please.
Yeah, so here's the bullet.py. We had to update. It now takes a new parameter, which is going to be alien group, right? Before, all we had here on our bullet.py was just the fact that it was going to move, but we added this functionality. On line 15, we did pygame.sprite collide. This is a built-in method that comes with the sprite class that as a parameter, it takes two groups. One is what group are we comparing it to? And it just belongs to the bullets. We want to compare it to the bullets. So we're going to take in self. The second argument is going to be whatever group you're trying to compare it to, whether you want to check if they've touched or not, right? If anything within these two groups have touched. And if so, the next argument is going to be either true or false. It's going to be a Boolean. This pretty much says whatever true or false it is, it's going to either remove it or not remove it. If it's true, then the group on the second parameter is going to be destroyed. That's what this Boolean is for. If it's false, then nothing's going to happen, right? So with this saying, hey, if the bullet, which is self, collides with anything in alien group, then remove it. That's all you need to actually work with the collision. We're just checking collisions, therefore removing it. Then line 16, 17, we're getting rid of our bullets if they pass above our screen. So we're checking the bullet. If self.rect.y is equal to -50, then I want to do self.kill. This will remove the object from my sprite group. Are you good, Kara?
Yeah, I just have one error that I can't get past. I think it's in my alien object. Basically, when I go to print alien object, that's why I just keep getting like alien sprite in one group. Like it just keeps saying one over and over again. And so it's
That's
not.
probably within your main.py whenever you're.
Yeah, it is.
In it. Yeah.
I just don't know what's wrong.
Oh,
Probably a typo somewhere.
Yeah, it tells you on the line it should be on.
Yeah, except that I don't know, it's weird. I'll show you.
Yeah, go ahead and share. Sharing.
Let me make it make sense for sharing. Okay. Okay. Can you see my screen?
Yep.
Okay, so if I run this, it just kind of breaks.
It breaks, you say?
Yeah, well, because it opens and then it crashes, and then this is what I've got going on.
I only see like a small part of your screen. I'm assuming you're sharing some kind of.
Hold on a second.
You're sharing some sideways monitor.
Yeah, I am. Hold on. I got it.
I see your message, Adrian. We might. That's gonna be part of the exercises. We'll get to that in a bit.
This is easier.
Okay, so they say no alien has no attribute image, and that's happening on line 68 when you're drawing it.
Yep.
You have no attribute image because let me see your alien class. Self.image. You have .rect, you have .image. Okay, and then you're drawing it. Why is that saying on 573? Huh. You do self, okay, init, yep. You load up your assets, spawn aliens. Alien object has no attribute image. What? Go to line 68 in your main.py. All aliens dot draw on the surface. Go to wherever you create your aliens, please. That's correct. Okay, in your so you got it there.
Recording in progress.
Who's alien? You guys know who Avia is on the call? What was that?
Sorry about that.
Oh, okay. I just want to make sure it wasn't like ISIS or something, you know?
My computer's lagging. I'll try to restart everything and I
It's
connect
okay.
with my
I'm gonna
phone.
pause the recording so we can do some deep.
Yeah, no, it's fine.
All right, so we got up to the self-kill
sorry.
method, right? So that takes care of destroying the enemy. But now we need a way to lose. Well, it turns out we can use the same sprite collide method, but with just our spaceship object, right? So within the game loop, we need to be able to check if our hero has made contact with the aliens. If so, we want to stop the game. Okay. So what we're gonna do is we're going to what you call it? Where's it at? Let me look at my ship. Okay, we got spawn timer. Okay. Okay. All right. So within our game loop inside here, at the very bottom, after we've done all this logic, I want to do something. All right. After we draw the aliens and the bullets, I want to do an if statement. It's gonna be if pygame dot sprite dot sprite collide, right? The same thing that we use within our bullet class, we're gonna use that here. We want to check. The first argument is gonna be the first item we want to check. We want to see if our hero has touched the aliens. So if self.hero, actually, what's the name for me? Mine is spaceship. My bad. Spaceship. So if my spaceship, that's gonna be my first argument. My next is gonna be the alien groups. If my spaceship touches anything within the alien groups, I'm not gonna kill anything. I'm just gonna put false because I'm not trying to kill anything right now. I just want to do pygame dot quit and it says dot exit. These exact same functionality that I put for my on the top right here to see if my user clicked the X button. I just want to exit out. Now, is this a nice game? Not really. It would be better if they took damage or they lost a life, right? But I'm gonna leave that ability to you guys. So I'm gonna keep it like this for now. Just to show you guys that this is working. So that's gonna compare my ship against one of these aliens. So they're doing their business, yada yada. They're trying to get up to me, filthy casuals. It's taking them a hot minute. And then eventually they will touch my character, and it shuts down. Right? So that means I got hit. It essentially I know that works because it went through with line 71 and 72 whenever it collided with my spaceship. So therefore, I can get hurt. Now, obviously, I can change this functionality and do something like if I got hurt, I can maybe create a method within my spaceship where and this is just just talking. I can do like define hurt could be my method, and it could be like I can create a data member above that's called like health. And I can say self.health minus equal 10, right? Something like that, right? But isn't that cool? Like just being able to do stuff like that, and then that should reflect whatever my health is. There's also ways to link, stuff from your classes like data members and draw it out on your screen. But that's going to be some function that I'm going to allow you guys to do on your own as a way to experiment and work with classes and objects. And that would be a much better logic than just quitting out the window. But for now, that doesn't really matter. The main point is the fact that we're able to work with objects and classes in the manner that we're working with it now, and being able to complete an entire working game. Like this is a working game. The only thing that's missing is a way to win. We can set a limit to how many of these we spawn. an if statement on the spawn timer or the event timer or whatever, or every time they spawn, we increase the count on one of the data members within the init that tracks the a certain limit, so it stops spawning them. And then if there's not spawning anymore and there's nothing in my sprite group, I can say you won, right? So we can do logic like that, with all within our classes, and I'm gonna leave you guys to be able to apply that functionality yourself, right? But overall, you have created your very first game. Congratulations. All right. Now, obviously, this isn't the best game off the block. It definitely needs improvement. We wouldn't want our game to close down every time we lost and have to restart it. We would also, we could use a game window in a way to win, or maybe a way to keep score. And if possible, maybe some health packs or power-ups. If you made it up to this point, you now have everything that you need to replicate either your own game or make improvements to the one that we just created. All right, so for additional practice, if you scroll down on the README, you're going to find a couple of exercises. This is what we're going to be working on tonight for the remainder of our time, and then come tomorrow, right? We'll finish with all these exercises, and then Friday is gonna be a review of everything that we've covered. But for now, if you read through the exercises, exercise 1 is gonna be add a feature that allows the enemy class to attack our player, right? We're gonna ensure that each instance of the enemy can attack. So we're gonna want to create an event for it, add some collisions to their attack to be able to hurt us, and feel free to add your own images or just create another shape like our bullet, right? But obviously change its color so we're able to distinguish our attacks from the enemy, so we don't get confused. The user doesn't get confused, right? Now, I said feel free to add your own images if you want. It's not mandatory. The main point of these exercises is to be able to work with classes and objects. But if you weren't on camera, I was talking to Kara about possible websites that you might use, and you can check out this nice website called itch.io. It is mostly a free website. You can come here, and on the top left, you'll see this tab where it says Browse Games. You're able to find indie games that you can either try out yourself, or what we're going to be using it for is going to be our assets, right? The asset is going to give you, a majority free art that you can use for your own games. Some of them will be locked behind some kind of purchase. I'm not trying to promote this website or some of these stuff. Please don't spend money. About 80 to 90% of the assets you'll find on this website are free. Granted, they might not be the most appealing, but if in this event that you wanted to add something cool instead of just a regular circle like I use, you can come here and look for a bullet. Please don't spend more than 10 minutes looking for a bullet. If you spend an hour looking for a bullet, it's a waste of your time. All right, so I would advise just stick to the circle, and then on your own time, if you want to improve it and look for assets, you can. I'm just displaying this and showing you in case if during your own time you want to look for stuff. All right, so you can come here, you can find your own assets if you like. But anyways, yes, that's gonna be the first one. Exercise 2, I want you to add a scoreboard. All right, so Pygame has methods that allow you to write on the screen and even keep count, right? So you're going to attempt to increase your score count every time that you destroy one of the enemies. Pygame does come with default fonts, so you can either use those or you can download your own fonts. There's font assets out there, believe it or not. You don't have to just use the default fonts. Don't waste time looking for fonts. But I just wanted to let you know that that is available to you if you wanted to. Adding music and sound effects for our classes. The game doesn't really have much of a mood, and it seems kind of dull. You can attempt to even make a death screen and a death sound animation. How will we do that? Well, how do we add a death screen? Well, whenever we run, we have our initial game loop. What if we only run this if we're alive, right? Or start is equal to true. But if start was equal to false, I want to run something else. That is still logical. You can still add that within your game loop. So while true, if start is equal to true, then run everything here. If not, run something else. So you can make a whole different screen that can appear prior to running all this, right? obviously you're still gonna require some basic game logic like the quit, but everything else, like from line 41 to line 72, you can indent this inside another if statement. You know, if star is equal to true, then run all this. If it's not equal to true, that means we're running the main menu and we can have another service there. So, you know, feel free to work with that and manipulate your game class. So that's going to be one assignment. Exercise 4, give our player more lives. Up to this point, we get hit once. Our animation window closes up, and that's no fun. Allow a player to be able to have a couple more chances if he messes up. It would also be nice to be able to see what our lives counter looks like. You could add a basic counter on your display, maybe create a class for that or a data member in your class, right? You might want to add that to maybe the game asset or the ship, whatever you want to do. It's up to you. If this is mainly so you're able to work with your classes and have that as a nice exercise. And then finally, but not least, if you even make it this far, our enemies are too slow. Do you not attack fast enough? Add a power that spawns randomly around the game at random times in random locations that can either increase your movement speed, attack speed temporarily, or even slow the enemy's movements for some time to allow for easier kills. How we do that? Maybe create another class called Power Up class, right? Or some kind of stuff like that, or like a Power Up class or lootables, whatever you want to call them, and then implement that other class into here. So it's gonna be our final assignments for FOP. Right. So do take advantage of this. I will break you out into the same teams that we were in earlier. If you guys have any questions, I'm going to stay here in the main room for anyone that needs any kind of debugging or any questions that you might have before you get back to your groups. But you will be back in your original groups that you were earlier. And without further ado, that's going to conclude today's recording.